The topic is solving absolute value equations and inequalities. So let's solve the first example. 6 plus absolute value of x plus 3 is strictly less than 2. Alright. So first what we want to do, it kind of look like number 2, but we need to get rid of the 6, right? To make it look like number 2. Right? Because we have strictly less, we have strictly less. However, if we try to do that, look what is going to happen. Absolute value of x plus 3 is less than 2 minus 6 is negative 4. It doesn't really, because if you notice, k has to be a positive number. Right? If k is every time we have k to be negative, it's kind of like one of those trick questions. So absolute value of x plus 3, so you don't really use these formulas when you have k becoming negative. You don't use all this from 1 to 4. So all you use is number 5. So what does number 5 says? Number 5 says absolute value of any number is always positive. Think about it. Absolute value of 2 is 2, positive. Absolute value of negative 2 is also 2, positive. So we can never have a negative number. We can't have absolute value to be negative. So it can't be smaller than negative 4. Can't be negative. So what we say here, no solution. Now let's do example 2. Example 2 is kind of the same. There's equality, so we're thinking we're going to use number 1. However, let's first get rid of the 2 and the 5 to make it look like 1. When we try to do that, we subtract 2 from both sides. We'll get 5 times absolute value of x equal 1 minus 2 is negative 1. Divide both by 5 to get rid of the 5. Absolute value of x is equal negative 1 over 5. Again, our k happens to be less than 0. And remember, absolute value can never be negative. Look at number 5. So what do we say? No solution. Right? Now what else? Example 3 is a little bit trickier. So same thing. It's strictly bigger. We think most likely we're going to use number 3. So what do? We have to get rid of the 10. So 3 times absolute value of 2x minus 1 strictly bigger than 6 minus 10, which is negative 4. I need to get rid of the 3 to make it look like number 3. If I divide by 3, I get negative 4 over 3. Now again, my k happened to be negative. Again, I'm always going to look at number 5. What does number 5 says? It says absolute value is always positive. But what does this says? We're trying to find all the numbers such that absolute value is bigger than negative 4 over 3. We know it's always positive. So let me do it this way. Since I know this is bigger than negative 4 over 3, what does that mean? That means it's always true. Why? Because I know that, let me put it, how can I say that? I know the absolute value of 2x minus 1 is always bigger than 0. This I know. Therefore, if it's bigger than 0, that for all x's, let me say that for all x being a real number, for all the real numbers, it doesn't matter what x plug in there, is going to be bigger than 0. Now, since it's always bigger than 0, anything that's bigger than 0 is definitely bigger than negative 4 over 3. Right? If this is bigger than 0, then it has to be bigger than negative 4 over 3, right? Here is negative 4 over 3. Here is 0. If it's bigger than 0, of course if it's bigger than 0, if it's here, of course it's in the right of negative 4 over 3. Now, since this is bigger than negative 4 over 3 for all real numbers, then the solution would be all real numbers, and this is the interval notation. And you can check it. You can plug any x in here. What's going to happen when you plug an x? You multiply it by 2, you subtract it, subtract 1, when you take the absolute value, this number will be bigger than 0, which means bigger than negative 4 over 3. So it will work for any x. So every time, let me put it this way, every time you have absolute value of some quantity bigger than some k, which happens to be negative, the solution will always be negative infinity to infinity, always. And that's it for this example.